How can we interpret information or data without monitors? Many of the monitors that we use today are LCD monitors. That stands for liquid crystal display. This is a display that has liquid crystals that a light is shone through from the back. It passes through a color filter and then finally to our eyes. This combination of light, filters, and color is how we're able to see information on these displays. Prior to LCD technology, we were mostly using large glass display tubes to be able to show information, so these LCDs provide us with some significant advantages. One of the advantages is that these displays are relatively light. We can put them almost anywhere. We can hang them on a wall, they can be part of a portable system, and we can effectively take this display anywhere. These also use relatively low power, so they're perfect for our mobile devices that run on battery power, and they are relatively inexpensive. The low cost of these displays means we can use them for practically anything where we might need some type of visual feedback. Because we're shining a light through polarization filters and color filters, it's somewhat difficult to get a true black color from a liquid crystal display. These displays also require that backlight for us to be able to see this information through those polarizing filters and color filters. Without that light, you have a very dim screen that is very difficult to read. That's why the backlight is so important. On older LCDs, you may see fluorescent lights being used for the backlight, but most modern LCDs will use LED lights or light-emitting diodes to produce that light. These lights can also be somewhat difficult to replace. On larger LCDs, you may be able to replace a portion of the backlight, but on smaller, less expensive systems, you may require a complete replacement of the display. There are also different technologies that we use with liquid crystal displays. One of these is a TN version of an LCD. The TN stands for Twisted Pneumatic. This was one of the very first types of LCDs that was introduced, and it provides very fast response times, so it's perfect for things like gaming or very fast-moving information on the screen. Unfortunately, if you move off-center from that display, you'll start to notice that the color will shift as you move farther and farther off-angle. So if you have a lot of people that need to see that display, a Twisted Pneumatic LCD may not be the best choice. A newer style of LCD is the IPS, or in-plane switching LCD. This provides very good color representation, so if you're doing any type of graphics or video type editing, this might be a great display for you. But these can be a bit more expensive than the Twisted Pneumatic version of the LCD, so you may be paying a little bit more of a premium to be able to provide that excellent color representation. And somewhat in the middle between a Twisted Pneumatic and an in-plane switching LCD is the VA, or Vertical Alignment LCD. This also has very good color representation, although its response time is not quite as good as a Twisted Pneumatic display. And depending on the device that you're purchasing or using, there may be only one style of LCD available for that particular platform. So if you had the option to choose between different types of LCD, you might want to see what options are available and choose the one that's right for your purposes. As you can imagine, having a backlight in the display adds to the cost, the power draw, and the overall size of the display itself. But what if you could get rid of the backlight altogether? One style of display that has no backlight is an OLED, or an organic light-emitting diode. This type of display contains an organic compound that, when you add power to that compound, creates and emits light. This means that you can have a high-quality, high-definition display without any backlights in the display at all. This means your display can be much thinner and much lighter because there's no backlight component behind the screen. And you may already be using an OLED display in some of your mobile devices. It's very common to find OLED on mobile phones, watches, tablets, and other mobile devices. And of course, you could choose to get much larger displays in different styles, including one that might be OLED. And because there's no backlight, you can get very good color representation on an OLED display. So if you're someone who is working with graphics, images, or video, you might want to consider an OLED display. The industry is constantly battling to find the best price point for OLEDs versus LCD. And one of the innovations on the LCD side is to create a backlight which provides a much better color representation. One of the ways that they've done this is to create a mini LED backlight. This is the same backlight that you would have in a traditional LCD, but the size of the LEDs or the light-emitting diodes is much smaller on a mini LED display. These displays also provide control of each individual light in the backlight, so the display can make the decision on what section of the screen should be lit and what the intensity of that light should be. This means that if the image on the screen was a darker image or completely black, the screen itself could turn off those LEDs to be able to make that black as deep and dark as possible. This means that the less expensive LEDs can come much closer to the color representation that you might find in a traditional OLED display. And if you were to remove the screen and look at the backlight on these displays, you would see there is a big difference between the conventional LED and the mini LED. You can see that the mini LED provides a much more granular control of the backlights, and you can get a much more nuanced view of the display because you have many more lights to choose from. On our watches, our phones, our tablets, and some laptop computers, we have the ability to touch the screen to provide input. This uses a digitizer to tell where we might be touching the screen, and it converts that touch into a series of coordinates. This means we can get rid of keyboards completely and simply use our screen as the input. But of course, you will still find laptops and other mobile devices that give you the option to include a physical keyboard as well. This gives you different options for input. We can use a mouse, a digitizer, or we can use the keyboard that's built into the system. This means that we could use the right type of input for the task that we have at hand. Some tasks may require a keyboard, but sometimes touching the screen would be a much easier way to provide that input. Many of these digitizers can not only recognize a finger touching the screen, but it could also use a stylus to be able to provide that input. A stylus is very similar to using a pen or pencil, except you can touch the screen and have any of those touches converted into a digital form using this digitizer. This is a very common input type for things like a tablet, but you might also find these digitizers used quite a bit on laptops or even desktop computers. As you are now aware, if you have a liquid crystal display, then you also have a backlight. And those backlights could be a fluorescent lamp or the newer LED type lamps. One of the challenges with the backlight is we need to provide power. That power for an LED uses the built-in direct current or DC power that we use to power our laptop. But if we have an older style liquid crystal display with the fluorescent lamps, those style of backlight require AC or alternating current. Since our laptops are using direct current, we need to invert that current so that it is now alternating current and can be used by our fluorescent backlights. One of the ways you can tell if the backlight is working or not is you can turn on the device and then look at the screen very closely. It often helps to have a flashlight that you can shine directly at the screen because that light will reflect from the back of the display itself. If you can make out text or graphics on the screen but it's very faint, then your problem might be with your backlight. This means that we would need to replace the backlight itself, or in the case of a fluorescent backlight, we might need to replace the inverters that are built into this device. These are very common on laptop computers, and you may find these inverters in the bezel of the display itself. You can check with the manufacturer of that laptop to see what style of backlight is in use, and if it is a fluorescent light, you can also check to see where those inverters might be and what the process might be to swap those out for a new one.